Hey everyone, it's been a long time since I've been on the workbench. Uh, Life's been keeping me busy, and in the meantime, I've actually upgraded some of my equipment. I got myself a wireless lavalier mic, and then some new multimeter, and I got a new computer, well, a new laptop. So now I'm recording on using a laptop, not my old desktop. So I went from an old 6-core machine to a 8-core 16-thread Ryzen 7. So hopefully, running 4 1080 streams. It's at 21% CPU, so we should be okay. Um, so before I get back into, I need to finish off replacing some backup batteries on some sharp Zauruses because I just have not been in my workshop in ages, and then back on the learning computer after that. But in the meantime, what I've run into is um, for years I've been making these Atari 5200 controllers out of Jaguar controllers, which is this guy here. The problem I'm running into is one, it's digital joystick only, and I've been promising for years to come out with an analog one. There are some analog solutions out there, but they're not like the easiest to set up, and they use um, digital potentiometer on there, and it takes a bit of fiddling. I'd like to find like a true like analog solution to it. And two, these guys here are getting crazy expensive. When I first started making the controllers, one of the reasons I went with the Jaguar controller is a little behind the scenes here. I was able to buy like two of them for like $30. So it was like $15 each shipped. Now there are now they are $50 to $60 shipped for one. So I've had a 400% increase on my cost of the parts. So that's why like I've had to raise my prices more than I like, because it's like otherwise there's no point in me making it because I'm not making any money. Even now I don't make that much money off these because just the amount of labor that goes into it, and trying to source these controllers is. I mean, I used to have a stockpile of them, but I've burned through all those, and it's like we're just Atari only made so many. So, all right. So I'm working on a couple parallel paths here, and one of them is I actually did all the math, and I can make a nice big old controller using a box like this, a nice arcade controller, arcade buttons, a nice keypad, a dedicated 3-button pad for the start, select, and pause. For I think the total cost of everything was like $41 or something like that. And it's like, and then you'd have brand new everything, not modified, all freshly wired up. Um, Basically a brand new digital controller for less. And I'm going to work with my son designing a smaller version of the controller, more Jaguar size instead of this big old box, uh, and 3D print it instead. Yes, I got him a nice 3D printer for Christmas, so we'll be able to make that. And the 3D printer is also going to be used for. I'm going to be making some cartridges for the Tiger Learning computers we're going to be working on. So for tonight, before I jump back into clearing out those Zori and then getting the work on learning computers, been some breakthroughs on how to do ROM dumps and how the cartridge works, which is actually more of a disk controller. So uh, I've got some really good information, so I can actually make some headway on that. So for now, trying to get a working analog controller for the 5200. The 5200 was a strange beast, and that's why you see my oscilloscope up over, and so what you're going to see is the this right now, what I have hooked up is a couple things. So this is the guts of one of my, this is my prototype one I keep here of the Jaguar to 5200 conversion, and it's a pure digital conversion. This uses a couple potentiometers that are hidden under here. This is an actual 5200 controller. It had this really interesting way of doing the positioning. Traditional modern joystick, analog joystick, uses two usually 5K low friction pots and the little thumb controllers you use, and they're just monitored. They just put 5 volts on one side, they put ground on the other, and they just measure a voltage. So you get 2.5 volts is centered. And when the machine boots up, it's like, okay, that's your center. So if you skew off a little bit, you'll be okay. So 5200 actually reads the resistance of the circuit. And it does that by, let me nerd you out here a little bit. Let me blow up this oscilloscope a little bit. It's a little out of focus. Hold on a second. All right. So, get this in focus. All right. So, oh man, I'm going to block my own face. All right. So, this guy here is Scope Probe 1, which is the yellow trace you see on the screen, and then this is the Scope Probe 2, the blue trace. So this is your X, so you're going left and right, and this is your Y going up and down. And they had this whole like super complicated slider arrangement, and there's like one lock, this is your Y here, and this is your X up here. So this whole thing like pivoted on this little spot down here, and the centering was done with a now dead rubber boot. Not a very great design. Anyway, so the problem is you can't just throw in a modern controller in there because it's just the resistance is all wrong, and the way they did it is on one side, you can see me moving this around, on one side of the pot of the, this is actually the center wiper of all things, it's just a 4.47 volt input, and then they pulse the, you can actually see they pulse it down. So if I go left, you can see, well, that's actually kind of interesting. On the left here, this is actually the Atari age. They have a multi-cart, so basically get both games. So if you hold down the diagnostic button, you can actually get the, this is the controller one, XY, so that's this guy here, and this is the XY pairing on the original controller. You see as I go push off to the right, that number goes to E4. Oh, why won't you stay in focus? E4, and you can see it's always around 60 hertz, but the average is down to 1 volt, and the peak to peak is 2.38. But if we swing the other way, you can see the, now we're pushing to the left. See how we're 0, E0 almost. This is hard left, is you'll have 0, which basically you have a more or less short across it, so you don't, the reason the bottom one's freaking out because my trigger's on channel 1. So as you come over, see those numbers going up, 27, 30, it's in hex. So I know around 7.2 is centered, 7.172. So I'm going to slowly move her over until she's centered. Too far, kind of touchy. There, okay, so that's centered. So they're both centered right now. They're bouncing around 7172, not 7172 because it's hex. So say 7172. So I know what this, it's not actually measuring resistance, it's measuring impedance. So you can use a smaller resistor, but you put a capacitor in parallel with it, and that changes your reactivity of the circuit or increases your impedance. So what I wanted to try tonight is move this out of the way a second so you can see me. So I want to try tonight is these are, I'll show you here. These are inexpensive little 1 mega ohm pots. So even I like trying these little industrial joysticks here. These little guys. I even have this little guy here, which is a nice joystick end. And again, these don't even cost that much. Well, since I'm here, I'll show you this one right here. All right, so let me close this back up. So this is your traditional. Move this out of the way too. You can see what the heck I'm doing here. All right, so this is your. If you ever open up a PlayStation or Xbox controller, this is what's under the analog sticks, and these are little 5K pots, and they have a nice little spring centering mechanism. They don't use a rubber boot, and that's what snaps them. And there's a little pot there, and then you have industrial joysticks. Get me a little closer, but they're only 5K or 10K. I found you can actually pop it off and put. Right now I've got a 2 mega ohm, so what I'm trying to do is get the swing right on it, but I can't quite get low or high enough, or I need to try it actually. So I'm gonna grab my pliers. I'm lucky enough, I've got enough swing. Where are my pliers at? I'll do the Y. Come on, you can do it. All right. So if I try something silly like just putting it on a regular, this is a 10K potentiometer. It's basically shorted, and it barely picks up anything. So I did go ahead and make put on the center wiper, and put on the lower wiper, see if that does it. I can't remember which one it is. Yeah, see? It's either open or I'm shorted. Little bugger. I wonder why it's doing this to me. Shouldn't matter. No, I want this on here. This guy on here. Yeah, see, I get some swing, but you can see I'm already, I can only go from D2 up to 2A. So closer, but not perfect. So I want to try different things like going down to say like a 1 meg pot, which is this guy here. You can tell it's a B1M. I'm sure I can actually get the swing where I want it to, but I only have about 60 degrees of throw. Go from A. I have to turn it way too far to get that range. So I'm thinking is throwing some capacitance on there. Where's my other? Oh, that is just not staying on either. Okay, there we go. So if I put this on here, put this guy on here, like so. So it's a little low right now. Let's see if I can make it look the same. Okay, so those actually look similar now. If I throw, I ordered some more caps, but let's see what I have now, how much of a difference it makes. If I throw it, this is a 1 picofarad. Oh, this camera never stays in focus. That's why I stopped using it. You see, it's right at 60 hertz, 59.9, which is what I would expect in North America, because there's already going to be a clock in there for the screen. It's running at 60 hertz. Let's see if I put this on here. Let's see, what do I am at? I'm at 7.6. Put this on here. 7.7. It's not really making much difference. So then I have big old, not big, but relatively larger electrolytic, and this is a 0.1 microfarad. So it's a lot bigger. If I do this, this should change it. Yeah, see, that brings it way down. There's your 1 microfarad. Now I can have to turn it. It makes it much more sensitive. This is what I was looking for. I can get a nice E4. Oh, this might actually be the trick. So a 0.1 microfarad cap on a, this is only a one, let me see if I can poke this in here. If this works, that means we all can come up with a better solution without using all sorts of digital pots and stuff you gotta program. So this swings real nice. I'm only swinging it through. Oh, that actually should work out pretty nicely. There we go. That's nice and sensitive. 0, E4. Ah, perfect. So now I know. Talking to myself here. A 0.1 microfarad across a 1 meg pot. I'll still have the mod. This is a 2 meg pot, so this is going to be too big. It's also too touchy when you use that high resistance. So I've replaced this carbon, which how these work inside is they're just they're a wiper assembly. So on this side you have this is a carbon film. This is a carbon film along here, And this is a little wiper that moves along the carbon film. That little tiny thing right there is the wiper. So yeah, and then that should work. And there's actually two wipers here. One's for the center and the other one's for the outside. So, and the center one is basically very low resistance around the whole ring, and then the outer ring is you go from, this is like 100K, 200K, 3, 4, 5, 6, 7, 8, and all the way out to a meg all the way on the other side as you measure it. So yeah, so that's a good thing. So I can take, these guys are super cheap. I can take this apart, take the assembly, drop it in there. The reason I took the back side of this one off, put it in there, and if I put a 0.1 microfarad, that should do it. I did order some 0.1s in ceramic because this is these little can ones are electrolytics and they can dry out and then they can go pfft. And if you hook them up backwards, they go pop. I don't want to do that. So, okay, this was a good discovery tonight. So, once I get my new caps in, I will build up an analog controller, one of these guys, test it out, and then I'll have a true analog 5200 controller. And I know people have been wanting it for a long time, and if I can do this, that means you don't need to worry about anything exotic, no circuits, no extra things. Just swap out the potentiometer and throw a cap across it, and there we go. We have analog control on the 5200. And then instead of doing a digital control for my new controllers, I'll do an analog control. And cost of that will still be really similar to the Jaguar controller, actually, if not even a little less expensive. So, wish me luck, everyone. Thank you for watching. Excuse me. Again, it's been a long time. Wife's about 3/4 of the way through chemo right now. Time-wise, she's gone through 10 treatments, and she's got 6 left. She's got the 7th one tomorrow, 7 of 12 of the weekly ones. So I'm going through that. So we just need to decide what kind of surgery she wants because we're going through the whole gamut. She's going through chemo and surgery and radiation and hormone therapy afterwards, hormone blocking therapy. So she has to make a decision of like, what kind of, is it just going to be a lumpectomy? Is it going to be a mastectomy? I mean, it's her body, her choice. So I don't know. It seemed the only problem with mastectomy seems like a major surgery to me. So the lumpectomy is going to be a lot quicker to recover from, and the survival rates, believe it or not, are no different between the two. So go figure. But yeah, everyone, thank you for watching. Sorry for a little bit of heaviness at the end there. Yeah, looks like I get my parts and I'll build up, and then we'll be good to go. I'll put it up on the website once I'll get a prototype up and running, and I'll make a duplicate of it because I'll just cut it on the CNC, and then yeah, we're gonna have a nice ambidextrous analog controller for the 5200.